All right, so what is the conjugate of 9 minus the square root of 5? All right, so we know it's 9 plus the square root of 5. So when we multiply these together, what are we going to get, guys? 9 times 9 is 81 minus the square root of 5. So it gives you a total of 76. 76. All right. So remember, we're going to do a well-chosen one here. We want to multiply by its conjugate on the top and the bottom. So this one's pretty nice and straightforward. Take the square root of 2 and multiply it. You get what? 9 square root of 2 plus the square root of 10. And that's the best you can do. Um, 76 won't go into 9, and nor will it go into 1, and 10 doesn't have anything to take removed. So that is the final answer. Now we're factoring this right here. Now, remember we have a name for this thing. What's this thing called? If you have a power of 3, this is called a cubic. Now, there are two names we give this thing. One is based on the highest degree, and the second one is named off of the how many terms it has. If you remember terms, these are your terms. If you've got one term, it's called a monomial. Okay? If you have two terms, it's called a binomial. If you have three terms, it's called a trinomial. If you have 4 or more, it is called a polynomial. Okay? So in this case here, if I back this up, that is a cubic polynomial. Right? So you need to make sure you know how to name it. It will be important to know the name. All right, when we get to the unit. Do what? Correct, I can. Well, if I have 5 terms, 6 terms, 7 terms, it's still a polynomial. Just like when we do degrees, if we do a degree list, remember we started with constant, which means it's just a number. We have linear, all right, and then we have what? Quadratic, and then we have cubic. Oops. Then we have quartic, and then we have quintic. There are other names, but we will stop there, and then the rest are 6 through whatever degree. So we call it 6th degree, 7th degree, 8th degree. We don't give it any other names beyond that. Just like polynomial, I'm sure there's probably something for a 4th degree of some sort. There we go, what's needed here. This is by degree, and this is by term. We normally write it as degree, then term. All right, back to the other slide. So, as I was saying, this is a 1, 2, 3, 4 terms, which means that we solve this by, or factor this by grouping, and grouping will be really basic. It is really just the first two and last terms grouped, and what is common in the first group? Which would just leave u. Which means this one has to be a 2x minus 3 because it will factor. And what number would this be? A negative 4. So then you can kind of see this has already got a what? An x minus 4 there, correct? So the speed of the process on your factoring, you could go f of x is equal to 2x minus 3, and then x plus 2 and x minus 2, since those are conjugate pairs. How many solutions do you have? Addison says 3. How do you know that, Addison? because there's a 3 right there. All right? Your highest degree tells you. Now down here it says list the intercepts and their multiplicity. Anybody know what multiplicity means? Kate, what do you think multiplicity means? What do you think multiplicity means? Take a guess. Yeah, about multiplying. Multiplying is, what is multiplication? Repeated addition. So it's a lot of repeated things. So multiplicity just means we're looking for, does it repeat? Okay? So we're looking for repeat. So in this case here, if I have 2x minus 3, I set it equal to 0. I have x plus 2 set equal to 0, and x minus 2 set equal to 0. Does anything repeat? No. So therefore, we can just go ahead and add the 3, and we get 2x is equal to 3 divided by 2. So x is equal to 3 over 2. This goes minus 2, so I get x is equal to negative 2. Here I add 2, so I get x is equal to positive 2. So 2, 0, negative 2, 0, and 3 halves, 0. Most teachers will write M1 right here, which just says multiplicity of 1, but when I say multiplicity of 1, it means nothing to me, because I don't think a multiplicity of 1 actually exists. Because when you're saying multiplicity, you're saying, hey, it repeats. Oh, multiplicity of 1? What have you been smoking? Or what gummies have you been eating? You know what I'm saying? So, what's in your water bottle? You know what I'm saying? All right, so in this case here, I don't declare those multiplicities. But if you go to tutoring with another teacher, they're going to write that as M1. All right? So it really doesn't mean anything. It might help later when we say when you have multiplicities that are even versus multiplicities that are odd. But if you don't have a multiplicity, you're not doing anything there anyway, so it makes a difference. All right, y-intercept. You do an f of 0, and that would end up being what? 12. So 0, 12 is your... Now, my end behavior is mixed up. Remember, this has a negative. And I told you, Addison, yesterday, instead of looking at putting the infinity into your factors, we don't have to do that anymore. We can really just look at this number right here, Addison, that we were talking about earlier. We can look at that first term. So we can go 2 times infinity times infinity times infinity. Now, in this case here, we're actually doing what? Negative. So negative, negative, and negative. So what would you get when you multiply a negative times a negative times a negative? 3 negatives gives you a negative. So this is negative infinity, which means we're going down. As we go right, we're putting it in the same front term, and it would be infinity times infinity times infinity, and 3 infinities would give you infinity, which means we're going up. So in this case here, it's really kind of simple here. Here's the roadmap so you can see it. As we go left, we are going down. As we go right, we're going up. So your image should look something like this when you get done. That is all that it's trying to tell you. Okay? We're starting down and finishing up. This is the end behavior that you're looking for. Down, then up. I took infinity right here, and I plugged it into the very first one. I plugged it into that one right there, in my brain, right there, if it will let me. The one that's circled in blue right there in a minute, right? Because these right here are insignificant. These infinities would be smaller and would not be as large as the front infinity. So the front infinity is the one that really, really important here. And I put 3 negatives in there. It'd be a negative times a negative times a negative gives me a negative. And that's really all it comes out to be. We should know it's going down. All right? Now, going down here, and we're just going to graph it. Maybe. I'll just do it right here. All right. So I have all my points. I'm going to go ahead and label them. Remember, if I give you a grid, you can use the grid, and I would go ahead and label my points, try to make them equidistant, -2 and 2 there. And then 1.5, you can just do that. And then 12, you can do that. Just label them. Make sure you write them down. Then you're starting down and finishing up. Remember, it's got to be a sketch. So I want to look something like this on your paper. Then we're going to talk about this. Is it an even function? Is it an odd function? Or is it a neither function? Remember, we're talking about here, what are we talking about on these? What does even, odd, and neither mean? What are we looking for? Symmetry. Is there any symmetry with this? No, there's no symmetry. So this would make this a neither. Okay? I had somebody in A block say, hey, it's an odd function. Because it's x cubed. I said, does it go through the origin? Remember, the odd one has to go through 0, 0. It's not, so it can't be odd. Okay? It is not an odd function. It's got to have what we call origin symmetry or rotational symmetry. Even is y-axis symmetry. Just remember that, all right? I'll keep going over it, over and over, and eventually you're going to know it. Okay? So we'll just check those at the end. Done. Boom. Put a fork in it. All right, next thing we're going to do is we're going to go over our